Alright guys, so in this video we're going to be looking at some problems that resemble the test. Alright, so they're test level problems and we're going to see how to handle them. Alright, so before we go into that, let's go ahead and review the pretty much the most important sentence that we've looked at so far, the most important concept, which is the rigid transformations, right? So rigid transformations do not change the measure of the angles for figures, right? They don't change the measure. Okay, the length of lines or line segments, okay, they don't change the length of lines or line segments. So maybe we'll add in here, do not change. And they do not change parallel lines from being parallel. All right, so remember the last video we looked at parallel lines and they stayed parallel lines when we rotated, right? So when we translated, rotated, and reflected, right? Those are the rigid transformations. Okay, so let's go ahead and look at one of the problems. All right, this problem says each side of triangle ABC, okay, this is how you denote triangle. Each side of triangle ABC is a line segment. All right, side AB, okay, so the sides that connect the points AB of the triangle measures 12 centimeters. Side BC measures 16 centimeters, and side AC measures 20 centimeters. All right, so all they're giving us is they're just telling us the length of the sides right now. All right, so now what does it say? Now it says, suppose the triangle was rotated 90 degrees about the origin and then reflected across the x-axis. What would be the length of the sides of the triangle? Okay, maybe we'll zoom out a little bit. So what's important here is to look for keywords. Okay, so we're given the sides and stuff, right? We're given 12 centimeters, okay, 20 centimeters, 16. All right, but what's more important? What have we studied so far? What we've studied so far is rigid transformation. So what's important to notice here is that you see it says suppose the triangle was rotated. That's an important word. Okay, so we should probably highlight it. Okay, let's highlight it yellow. Okay, so here we have rotated. That's very important. 90 degrees about the origin. Okay, and then reflected. Okay, that's another important word, right? Reflected across the x-axis. What would be the length of the sides of the new triangle? Okay, so we know rotations and reflections, they don't change the length of the sides. Okay, so it's kind of like it's just testing it's just testing if you know the concept of rigid transformations, right? So what would be the answers to this? Well, the answer to this would be it would just be AB. What's AB going to be? So side AB, they tell you it's 12 centimeters. Then they tell you it got rotated. Then it got reflected. But rotations and reflections don't change the length of the sides. So AB is still 12 centimeters. Same thing for BC. Okay, BC was what starting out? 16 centimeters. What did we do? We just rotated and reflected. That's not going to change the length of the side. So what's BC going to be? 16 centimeters. It's going to stay 16 centimeters. How about AC? What did they tell you AC? They told you AC measures 20 centimeters, right? But that doesn't matter because rotations and reflections don't change the length. So you just get 20 centimeters again. And that's it. Okay, it's that simple. You just gotta read the problem a little bit and look and find the keywords. Okay, the keywords are the most important. All right, so let's go look at this next example. This next example is number 2. It says a triangle is drawn on a coordinate plane. Okay, just the XY. It says angle A. This is how you refer to an angle, right? An angle. You guys should know about some angles. It says angle A measures 30 degrees. Angle B measures 60 degrees. Angle C measures 90 degrees. And it says if the triangle reflected over the x-axis, what would be the new measure of each of the angles? Well, what's the key word here? The key word here is reflected. What do we know about reflections? Do reflections change the measure of angles? No, because reflections are one of the rigid transformations. So it's another concept question. It's kind of like a trick question, okay? Because it's so easy. If the triangle got reflected over the x-axis, what's the new measure of each of the angles? Well, the new measure is just the same measure. Okay, so angle A is still 30 degrees. Angle B is still what? What did they tell you angle B was? 60 degrees. They told you the triangle got reflected. That doesn't matter. Angle B is not going to change, so you still get 60 degrees. They told you angle C was 90 degrees, and they got reflected. Does that matter? No, it's still going to stay 90 degrees because rigid transformations preserve measures of angles. All right, that's it. That's straightforward. All right, let's go to number 3. Number 3 says, suppose there are two angles in a coordinate plane. Okay, so there's two angles in a coordinate plane. One of the angles measures 85 degrees and the other measuring 150 degrees. All right, no big deal. Suppose that both of the angles are rotated. There's a key word. That's important. So maybe we'll write it down or highlight it. Suppose that both of the angles are rotated 90 degrees and then translated. There's another good keyword. Okay, highlight that. 50 units down. What are the possible values for the measure of the angles? Well, the only possible values for the measures of the angles are the same measures of the angles you started with, because these angles aren't going to change. We're just rotating and translating. All right, so what could you say here? You could say the possible, maybe we'll put a different color. So let's go to home real quick. Maybe we'll put the answer in, I don't know, purple. So we'll say the only possible values for the measures of the new angles are the original values of the angles. So the only possible values for the measures of the new angles are the original values of the angles, because they're not changing, because we're only rotating and translating. That's not going to change the measure of the angle. All right, so the only possible values for the measures of the new angles are the original values of the angles. Okay, which were, so maybe we'll say which were 85 degrees, and what's the last one? 150 degrees. Okay, that's it, guys. Okay, it's that straightforward. All right, rotations, translations don't change the measure of the angles. So what's the possible values? Only possible values are the same thing. Okay, 85 and 150. All right, number 4. All right, number 4 says, let's number this real quick. Okay, number 4 says 4 students in a pre-algebra class each did an experiment. Each did an experiment in which they rotated an angle. That's important. Okay, maybe we'll highlight that real quick. So 4 students, in a pre-algebra class, they each rotated an angle in a coordinate plane. Okay, 25 degrees about the origin. Okay. The table below shows the measure of each student's angle before and after the rotation. Okay, we see rotation again. It's important because it's a rigid transformation. Who must have made a mistake? Select all that apply. Well, let's see what's going on here. All right. So they tell us that these students right here, Zane, Julie, Kamani, we're going to put the right spelling on Kamani. Uh-oh. Let's ignore it. All right, so we have Kamani here. And so we're looking to see who got it wrong, right? So let's look at the students real quick. So it says the 4 students, they rotated an angle 25 degrees. All right. The table below shows the measure of each student's angle before and after the rotation. Who must have made a mistake? Well, let's see what happens. What happens when you rotate an angle 25 degrees? When you rotate an angle any amount of degrees, the measure of the angle should not change. Okay? So the person who got it right, the measure of the angle before the rotation and the measure of the angle after the rotation should be the same. Okay? So Zane here, Zane said it's before the measure of the angle before the rotation, he said it was 35 degrees. But then when he rotated the angle, the measure changed. Okay? The measure wasn't supposed to change because it's a rotation. All right? let's look at the next one. Let's see what Julie said. Julie said 48 degrees. Um, Julie said the angle she rotated was 48 degrees, and after she rotated it, 52 degrees. No, that's wrong, because rotations don't change the measure of the angles. All right, what did Kamani say? Kamani started out with an angle that's 29 degrees. He rotated and still got 29 degrees. That's right. Okay, so right now Kamani is the only one who's right. Next we have DW. DW started out with 80 degrees for the original angle she's rotating, and then she ended up with 90 degrees. Okay, that's also wrong. All right, because when you rotate an angle, no matter how much you rotate, okay, no matter how much you rotate, you're still going to end up with the same angle. So now let's look at the question. The question saying who must have made a mistake. Select all that apply. Well, the person who made a mistake are going to be the people. Okay, so it's going to be more than one. It's going to be the people who changed the measure of the angle, okay, because they weren't supposed to change the measure because the measure of the angle wasn't supposed to change. So maybe we'll say who must have made a mistake. Maybe we'll say the people. Well, let's put the answer to different color. Home. Let's go. Let's do blue. Okay, so we'll say the students who made a mistake were Zane, Julie, and DW. Okay, so you want to read the question carefully. It's asking who made a mistake. Okay, the people who made a mistake were the people who changed the measure of the degrees. All right, and that's going to be it for this little example. All right, thanks guys. Thanks for watching. If you have questions, you can just go back and rewatch the problem. All right, thanks.